So the higher derivative to do higher derivatives, we're saying we'll do question, we can start from question 7. Right, question 7. Yeah. Find the second derivative find the second derivative of 1, y is equal to 2x squared plus sine 2x. So first thing is to find the first derivative. That is 4x plus 2 sine plus 2, the derivative of sine is cos 2x. That's the first derivative. So we use chain rule there. You differentiate sine and then differentiate the inside of it, which is 2x. So you get 2. And then you differentiate this again for you to have the second derivative. So 4x, you get 4. Now it will be minus 4. Derivative of course is negative, that's why you have a minus. And then sine 2x. So we have found the second derivative. Let's see. For cot, when y is equal to cot x, this is the same as y is equal to, you know, cot.
Just a minute before you proceed with this, and I've got a question.
Okay.
Where has this 4 come from? The one on sine.
So chain rule again, you differentiate 2x, you get a 2, multiply by this 2, you have a 4. And then differentiate cos, you get sine.
Okay.
Okay. So we say a cot is cos over sine. So if we apply ln, on the right we have ln cos minus ln sine. Then differentiate 1 over y dy dx is going to, the derivative of cos is negative sine over cos x minus the derivative of sine is cos over sine. So that our dy dx, when we cross multiply by y, which is cos x over sine x, we'll have cos x sine x, and then negative sine squared x minus cos squared x. So that this cos and this cos can go, and then we'll remain with negative sine squared x minus cos squared x over sine squared x over sine squared x. So that we get negative 1 minus cot squared x as the derivative of cot. Then we differentiate this again. So to find the second derivative, we have y is equal to negative 1 minus cot 2x which is the same as y is equal to, so now we need to get back to, anyway, life has become easy now. So just say y prime prime is equal to, derivative of -1 is 0. So we have -2 cot x, and the derivative of cot is what we have here. So -1 minus cot squared x. So that we have +2 cot x plus 2 cot 3x. This is our derivative. That's how we obtain, using ln, the first derivative, and the second using another method. Let's see y is equal to x over 1 minus x squared ln y is equal to ln x minus 2 ln 1 minus x. Assuming that you can see as you apply ln, then the power will drop after the subtraction, and then you have such a thing. Then you differentiate now. 1 over y dy dx, this is coming from implicit, and then 1 over x minus 2 -1 over 1 minus x. So we get dy dx is equal to, when you multiply by y, you get this squared, and then we have 1 over x plus 2 over 1 minus x, like that. So we simplify so that we are able to get a second derivative. So we have x 1 minus x multiplied by 1 minus x squared. So we get on top there x 1 minus x plus 2x. This can be simplified further to give us x minus x squared plus 2x over x minus x squared. In fact, before this, we can reduce our work by canceling one of the x. So this x and that x can go with this x, so that we just have 3 minus x over 1 minus x to the power 3. Wonderful. So now we have
sir. So this 1 minus x, sir.
Hello?
So this 1 minus x, both top and down, they can be cancelled?
No, because here there's no 1 minus x. You can only cancel if you're able to factor it out from top.
Okay.
Because here what you have done is you have put out x and remained with 1 minus x plus 2, and then you canceled the x by this one. So again, we bring back here and try to avoid using the quotient rule. So we bring in ln is equal to ln 3 minus x minus 3 ln 1 minus x, then 1 over y dy dx is equal to negative 1 over 3 minus x plus 3 over 1 minus x. So the derivative, which is the second derivative, we have to go back and say second derivative there, is going to be 3 minus x over 1 minus x or 3 is being multiplied by negative 1 over 3 minus x plus 3 over 1 minus x. Now we can leave it here. There's no harm. We need to go back here and say this is, okay, here we said y prime prime. Okay, where we did y prime prime, okay. This is the y prime prime, which I've said the 2y dx squared. It's also another way of representing y prime prime. Okay, let's go to d. Y is equal to x tan x. Ln y is equal to ln x plus ln tan x. What's the derivative of tan x? We have it, we did it that day. What's the derivative of tan x?
Sammy, honestly, I've forgotten.
Hey. Isn't it not this? Okay,
Yes,
so
it is, sir.
it is, yeah.
Yes.
Okay. So when you differentiate here, we'll have 1 over y, and dy dx is equal to 1 over x plus sec squared x over tan x. And so dy dx is going to be x tan x multiplied by, if we get the common denominator to be x tan x, then we'll have tan x plus x sec squared x. And then this part and this guy will cancel. So we remain with tan x plus x sec squared x is equal to y prime. This point now we cannot apply ln because we cannot separate them inside the ln. So we have to separate the odd way. Prime prime, the derivative of tan is sec squared x plus product rule. When you differentiate x, we get 1 multiplied by sec squared x plus you keep x and differentiate sec squared x. So it will be 2 sec x. Derivative of sec, we said it was what? It was sec x tan x. So we'll have 2 here and then sec squared x tan x. So that we get 2 sec squared x plus 2x sec squared x tan x. which is 2 sec squared x, 1 plus x tan x. Which is this one here as the second derivative. So to find the third derivative, you would find the derivative of this one and call it the third derivative. So that it's been long. I miss your to my handwriting, so you submit question 17, 1 and 2. The table sheet is there in the group. So to avoid excuses, 1 is x squared plus 2x minus 2xy squared is equal to 2, and 2 is y is equal to x squared 3x plus 1 over x4 plus 2. So you have these two to submit at least before 23:59 today. So that we end here. So you can use that method if you want. You can be using quotient rule, or you use the lean. Okay. Okay, so I'll wait and I'll send this, I think, shortly.
So have a good day.
Good day.
Thank you.